And welcome back. This is going to be hopefully just a short video on how to do the electron configurations and orbital diagrams, but with an abbreviated form, right? We're going to do these abbreviated. So all I've done is I've left the learning objective up here and I've just put abbreviated here. These are also called the noble gas configurations. They're called noble gas configurations. And so here's why. Let's look. I'm going to make this quick. If you look at a typical electron configuration, like let's say for sodium, how many electrons does sodium have? 11, right? So you see there's 11 electrons in sodium, so we write our electron configuration diagram like this. You've already seen in the last video how to do that by following the order. And you fill the 1s2 and then the 2s2 and then you fill the 2p with 6 electrons and then you fill the 3s with 1 electron. All right, and you stop there. Well, all of this extra stuff here could simply be rewritten as neon, right? Because neon, in brackets, always put brackets there like this, neon is essentially the noble gas that has basically that in blue as its electron configuration, right? Let me zoom in here so you can see the color. Here, in fact, here's neon up here. Okay, neon has an electron configuration of 1s2, 2s2, and 2p6 for its 10 electrons. Well, if instead of writing all of this for sodium, then you could essentially just write neon, put it in brackets, and then keep going. What's after all this? Well, 3s1, right? The next orbital that you will be allowed to fill, or that you have to fill, is the 3s orbital. And again, it holds 2, but we only need to put 1 there, so that's why we put a 3s1. And just jot that down right there after your noble gas in brackets. And there you go. There's your abbreviated electron configuration. And so let's just read this. Just kind of says the same thing, but to write an electron configuration for an element, first find its atomic number from the periodic table. All right, duh, that's how many electrons it has. This number equals the number of electrons in the neutral atom. Then use the order or filling from figure 9.23 or 9.24 to distribute the electrons in the appropriate orbitals. That's called that off-bow diagram. I encourage you to go online and Google images. No, please don't cut the one out of your textbook. I was joking when I said that. Go online. I'll put some on Google Classroom that you can choose from that have colors and nice and neat and easy to read. Or just construct your own so that you can follow that diagram. And remember that each orbital can hold a maximum of 2 electrons. And so here's where students will keep asking me, like, well, I don't get it. How can the d orbital hold 10 electrons when you're saying each orbital can only hold 2, and you're saying that the f orbital can only hold 2? It's kind of semantics, right? So they're using the word orbital here. Now they're calling it a subshell here, right? So I think of orbitals as shapes, and then all of the shapes that make up let's consider the d. Let's consider the d orbitals. All 5 of those d orbitals together collectively make up this d subshell. That's kind of a way to think about it. So I don't like to say p orbital unless I'm referring to the actual one of the 3 shapes here, or one of the 5 shapes there, or one of the 7 shapes there. And so, or if I use the word orbital there, I use the word orbital shape here. I don't know, but so it does get tricky because they use the term twice, orbital here, and they use the term orbital there. But the point is, each one of those shapes can only hold 2 electrons. And if you have 3 shapes, that's 6 electrons. If you have 5 shapes, that's 10 electrons. If you have 7 shapes, that's 14 electrons, right? 14, 10, 6, and 2. And so this is called noble gas core notation. They didn't really have a whole section for that, did they? But they kind of should have. And you can also do that with orbital diagrams as well. Like if you want to do these box orbital diagrams and you want to do an abbreviated form, only if I ask you for it though, because this is a complete orbital diagram. But if I wanted you to draw a noble gas one, you would find the noble gas that would just, you could put it in brackets and it would just basically re-represent all of this, and then add the remaining electrons that are valence electrons, or well, the remaining electrons that exist past the noble gas. I can't say they're all valence because you could still have subshells after that, but okay. So while we're here then in this video, let's look at an example of how we would do an abbreviated form, another abbreviated form. Let's see.